Okay, so we'll be looking on calculus, and calculus is into two sides, that of the differentiation and that of the integration. So today we are going to focus on differentiation. Possibly in our next class we'll do with integration. So for differentiation, according to the root word difference, which is talking about subtraction. Now that is what you do for differentiation. It is all about subtraction. That is removal. That's the removal of one. Now, for we to do this, there are rules that guides differentiation. Let's say, for example, if y is equated to axn. Now, what differentiation talks about is the y, the x, that is first derivative of your answer, and this is how it goes. Now, the y, the x of it becomes, that's differences of y in respect to what x, that is why it is called the y, the x, and then this becomes your power, your index. You would send it to the coefficient of your variable, meaning a times n, and then you maintain your variable. Now you subtract by 1. Now this will give us an x n minus 1. This is the y, the x of ax raised to the power of n. Same thing is applicable here, whereby we have, this is the first one, whereby we have y is equated to xn. Same thing, there is a 1 here, so we send our index to the back. So dy dx of this becomes n x n minus 1. This is the y dx of x raised to the power of n. That's the principle. Just send your index to the back of your variable. If there is a coefficient, you multiply it by the coefficient, and then your index is subtracted by 1. That is what guides differentiation. Then every other thing comes in. We'll be talking about chain rule, product rule, quotient rule, and then trigonometric function. Those are what we are going to cover for today. Now, after knowing this, let's pick some example to work on. Okay, now these are some examples. It said find the first derivatives of the following. The first one, y is equated to x raised to the power of 5. The second one, we are having y is equal to 1 over x raised to the power of 2. And then the third one, we have all of that. So if we want to solve this, as I formally introduced, we send our index, which is our power, to the back of the variable and then subtract the power by 1. Now the y dx of this becomes 5 sent to the back. You maintain the x and then 5 minus 1. The y dx becomes 5x raised to the power of 4. That is it. Now if we do that of the second one, we have, though this is in fraction, but with our experience on indices, what you have to do when you have problems like this, try to straighten it up. That's make this a linear equation so it will be easy to solve. Now going back to our negative power law that we learned in our previous video, this becomes x minus 2. When it goes up, the index takes a negative sign. So a positive 2 becomes negative 2. So what we have to do is to go straight to dy dx. And now dy dx, as we know, send the power to the back, minus 2, x, now minus 2 minus 1. Now dy dx becomes minus 2, x raised to the power of minus 2 minus 1 is minus 3. Okay, now for the third one, Okay, now for the third one, everything is already set. Okay, I forgot to introduce this to you. Now this is a constant. It's not having any variable as these are having. This is having raised to the power of 3, x is having raised to the power of 2, this an ordinary x raised to the power of 1. Whenever you are differentiating a constant, it becomes 0. It is what trashed out. So if you want to find the y dx of this, the y over the x becomes, we send this to the back, this is 3 times 4, 12, then x becomes 3 minus 1, which is what, 2. Then we have minus 2 times 2, it is 4, x, 2 minus 1, 1. Then plus, when you differentiate x, you have what, 1. Because it is x, that one is sent to the back to become 1x. Now 1 minus 1 is what, 0. And you know anything raised to the power of 0 is 1. So this is like 1 multiply 1 to get 1. So whenever you are differentiating x, you just get what, 1. And then whenever you are differentiating a constant, it is what, sent out. Now this is the first derivative of 4x cubed minus 2x squared plus x1 plus 1. Now that is the introduction of differentiation. Now there are different functions of differentiation. Let's see functions of differentiation. There are different functions. We have the derivative of chain rule. Let's put the different one that we'll be checking on. We have that of chain rule. We have product rule. We have quotient rule. We have trigonometric function. We have that of logarithm function. Okay, let's take them bit by bit. Now, that of the chain rule. The chain rule, if we are to pick that of the chain rule, it is an introduction. When you want to solve the y dx for chain rule, you are going to introduce a variable u. We've been dealing with yx, y in respect to x, and now in chain rule, we are going to introduce u into it. The introduction of u comes like this. Now, for chain rule, the y dx is not going to be straight. It's going to be dy du times du dx, whereby we are going to find y in respect to u and then later u in respect to what, x. So there is an introduction of u in chain rule for dy dx. Now let's pick some example and then expatiate on what I've just said. Okay, now we are talking about chain rule, and then these are a typical example of chain rule. Now it said find the derivative of the following. We have number 1, y is equated to 2x plus 8 raised to the power of 4. Now, to solve this, I told you earlier on that we are going to introduce u. Now, to make it simpler, the first thing you do, let u be equated to all what is inside the bracket. Let u be equated to 2x plus 8. Now, if u is all of this, it means our y is what, u raised to the power of 4. That is the step you ought to take during chain rule. Let u be equated to this, and then y becomes u raised to the power of what, 4. I like taking this step. What I'm going to do is du dx becomes, then you are going to differentiate this. In differentiation of this is a constant. I told you, take away your constant. Now for this is a 1, and then when it comes to the back to multiply 2, it becomes 2, and then x, 1 minus 1 is 0, which makes it 1. So the differentiation of 2x is 2. The differentiation of 8 is what? 0, which is what? Gone. So du dx is what? 2 out from this. Now, the y du dx gave us this. The y du becomes, when 4 goes to the back, it becomes 4. Then u, 4 minus 1, that is what? 3. So the y du is this. The u dx is what? 2. Now, go back to our formula. The y dx is equal to dy du times du dx. Same thing, if you delete these two, you still have what? Dy dx. So it is just an introduction of u so as to make the whole thing simpler. Now, the y dx is now equated to dy du is what? 4u cubed times du dx is what? 2. And then the y dx becomes 2 times 8 is what? 2 times 4 is 8. Then we have u cubed. Now recall u was formerly 2x plus 8. 2x plus 8. Therefore, the y dx becomes 8 bracket of what? 2x plus 8 raised to the power of 3. That is our answer. Okay, now there is also a simpler way, but let's leave that. When we get to the product rule, I'll tell you what to do. Let's just master this and then continue. Now let's pick question 2. For question 2, I'm having y is equated to square root of x squared minus 1. Now, when you see something like this, it becomes difficult to what? Solve. But that is why your law of indices is very, very important. Now, the first thing, make this make it solvable. How do you do that? We have x is equals to, now, instead of the square root in index form or in power form takes half as is what? Index. Meaning this becomes x squared minus 1 raised to the power of half. This is called root power law in our indices, which we did formerly. X squared minus 1, our square root takes an inverse in the power level, making it 1 over 2. Now, what we have to do, we have to what? Solve. Now, for we to solve, introduce u. That is the success to chain rule. Now, let u be equated to x squared minus 1. That is u. What is inside the brackets? X squared minus 1. Therefore, y is equated to what? U half. Now, as I said, du over dx, du over dx becomes x squared, it is what? 2x. When 2 goes to the back, that's 2. 2 minus 1, 1, which is 2x. Now, minus 1 is what? Trashed out. Now, we differentiate y in respect to u. Now, dy du becomes half goes to the back, 1 over 2. U, half minus 1 is minus half at the power level. Minus half. Now, our formula, the y over dx is equated to the y over du times du over dx. Okay, so let's continue here to round it up. Now, what we have to do, we have our dy over dx. Our dy over du is half u raised to the power of minus half times our du dx, it is what? 2x. Now, we do our multiplication. Now, this u raised to the power of minus half is on its own. Every other thing can do the multiplication. In fact, everything is multiplying. Now, the y dx is now equal to half times 2x This is what I'm saying. Half times 2x, this cancel this, we are left with what? X. So this is x u raised to the power of what? Half. Recall, u was formerly x squared minus 1. X squared minus 1. Therefore, the y dx becomes x bracket of x squared minus 1 raised to the power of minus half. And that is our final answer. Okay, that's for the number 3. Please do that and then drop your answer in the comment section. We want to go straight to product rule. So try to fix number 3, use what we've learned, and then fix number 3. I want to see your answer in the comment section. Okay, now let's go over to product rule. Okay, now for the product rule, remember for chain rule, there was an introduction of u. Now, there is a slight difference. For chain rule, for product rule, now y is equated to uv. Now for chain rule, we said u was introduced, but now product rule, remember product means multiplication. Now y is equated to uv. Now there is an introduction of v. We've introduced u during chain rule, now we are introducing v. And if v is introduced, u and v are in respect to x. Therefore, the y dx in product rule becomes u dv over dx plus v du over dx. This is the formula for product rule. I gave you that of chain rule. The y dx is equal to the y du times du dx. Now this is for product rule. Now let's take some examples. Solve with this example. It said find the derivatives of the following. Now I'll solve question 1 and then the question 2. Maybe you try it on your own. I will drop the question 2 for you. Now that's for question 1. Now as I said, in product rule, you are having 2 variables, u and v, and they are all in respect to x. So if you want to do this, we'll say let u be equated to 3x squared plus 1. V to be equated to what? 2x plus 1. Now, we want to differentiate. Remember, u and v are in respect to x. So du dx becomes, we differentiate this, we have 6x, 2 to the back, 2 times 3, 6x, and then 1. So 1 is what trashed out. Now we do the v over dx. We differentiate v in respect to what? X. Now this is going to be what? 2, and then 1 is trashed out. Now the next thing, we bring our formula. The y dx is equals to u dv over dx plus v du over dx. Now the y dx will become u is 3x squared plus 1. The v dx becomes 2 plus v is what? 2x plus 1. And then du dx is what? 6x. So what you just do, open up the word bracket. So the y dx becomes 2 times 3x, it is 6x squared plus 2 times 1, 2. Now this multiply this plus what? 12x squared. 6 times 2, 12. X times x squared plus 6x times 1, 6x. Now the y dx becomes, when you collect like that, 6x squared plus 12x squared, it is 18x squared. Now plus 6x plus 2, and this is our answer on product rule. Okay, now for quotient rule, now this is product rule. Now for quotient rule, we said for product rule it is y equal u v. Now for quotient rule it is y equated to u over v. This is like the division aspect where u and v are in respect to x, just like the product rule. Now, therefore, the y dx is now equal to, now this is v du dx minus u dv dx over v squared. That is the formula for quotient rule. dy dx is equal to v du over dx minus u dv over dx over v squared. Okay. Now, we have an example here. It said find the derivative of x squared plus 1 over x plus 1 squared. Now, this is an example of a quotient rule. Now, when we want to solve, this is actually the question. Y is x squared plus 1 over x minus x plus 1 raised to the power of 2. Now we'll say, let u be equated to this, x squared plus 1, and v equated to x plus 1 squared. Now, having done that, the u dx becomes, the difference of this is 2x, 1 is trashed out. Now for this other one, dv dx becomes what we know formally in the rule that I gave you before, the short way to go about chain rule. This comes to the back to become 2. Then you differentiate what is inside the brackets. What is inside the bracket, the difference is what? 1. And then we have x minus 1 raised to the power of 2 minus 1. That is what? 1. Now this is 2 bracket of what? X minus 1. So this is 2 bracket of what? X minus 1. Okay. Now we continue. dy dx is equal to v du dx minus u dv dx over v squared. Now when we have it this way, dy dx, our v is this, x plus 1 squared. Our du dx is what? 2x. Now minus u is actually x squared plus 1. The v dx is 2 bracket of x minus 1 over v squared. This is our v. Our v is x plus 1, 2 raised to the power of 2, because it is what? V squared. Now we continue. The y dx, now x plus 1 square, it is still x square plus 2x plus 1. When you open up the brackets, when you make it in 2 places, now we maintain our 2x, then we have minus x square plus 1, and then we have, let's open up this, 2 times x, 2x minus 2 times 1, 2. Okay, over x plus 1. Now 2 times 2, our product rule, product power law in indices becomes 4. Now the y dx, we open up the bracket with this 2x times x squared, we have 2x cubed, plus 2x times 2x, we have 4x squared, 2x times 1, it is plus 2x. Now this minus affects everything. not just this, because if it affects this, automatically it's going to what? Affect this. Now, minus x squared times 2x, it is minus 2x cubed. Minus x squared times minus 2, it is plus 2x squared. Minus 1 times 2x, it is minus 2x. Minus 1 times minus 2, it is plus 2 over x plus 1 raised to the power of 4. Now we are going to collect like terms. In collection of like terms, we have the y dx is equated to, now this 2 is taken out because that is positive and that is what? Negative. Now we have 4x squared plus 2x squared, that is what? 6x squared. Now since it's 6x squared, we have the next one, 2x minus 2x, it is gone. And then we have plus 2 over x plus 1 raised to the power of 4. Okay, for derivative of trigonometric functions, remember there are 6 trigonometric ratios. Now I want to see the derivative of all 6 of them. Now the first one, when y is equated to cos x, the derivative of cos x is minus sine x. The second one, when y is equated to sine x, the derivative is just a positive cos x. And then the third one, when y is equated to tan x, the derivative is equated to sec square x. And then when y is equated to sec x, the derivative is sec x tan x. When y is equated to cosec x, its derivative is minus cosec x cot x. And then the sixth one, where y is equated to cot x, its derivative is minus cosec square x. Okay, now these are the derivative of all 6 ratio of trigonometric function. Now we can be asked for to find the derivative of the following, and then we are given the first one. You can be asked when y is equals to cos 5x. Second one, you can have even something like this. You can have y is equals to sec square x. Now, how do you go about this? This is an example on the derivative of trigonometric function. Now, let's pick it bit by bit. The first one, we have y is equated to cos 5x. Now, what you are supposed to do, this can also be answered with chain rule. Now, but even without that, just looking at it, what you have to do, differentiate this, and maintain your 5x. So if you are going to solve this, let's observe chain rule, and later we do whatsoever I want to do. Now let u be equated to 5x. U should be all of this, so we can have cos u. Now let u be equated to what? 5x. So it means y is equal to what? Cos u. Now if we find the u dx, it is now going to be 5. The u dx is what? 5. Now dy du becomes, now cos is what? Minus sine. So we have minus sine u. That is the derivative of cos u. Cos is what? Minus sine u from our derivative of trigonometric function. Now using our formula, dy dx is now equated to dy du times du dx. Now the y du is now equated to the y du, it is minus sine u times du dx. Du dx is what? 5. So when you multiply, the y du becomes minus 5 sine u. Recall, u is what? 5x. Therefore, the y dx becomes minus 5 sine u is what? 5x. This is the derivative of y equal cos 5x. If we are to find the second one, we have, for the second one, y is equated to sec square x. Now this thing is also sec x square. That is what this thing is referring to. When you punch your calculator and you're having sec square x, when you do that, you'll find out that it will give you syntax error if you type it directly like this. So the interpretation means sec x square. Now when it's like that, what you have to do becomes, let u be equated to x square. Let u be equated to x square. Actually, this is supposed to be for what? X. That's how it's supposed to be. So if u is equal to x square, our y becomes sec u. Now what we do, the u dx becomes 2x. And then the y du becomes, sec is converted to sec u tan u. Sec u tan u. Now what we have to do, we go back to our formula. The y dx is equated to the y du times du dx. Now the y dx becomes, the y du is sec u tan u times du dx, it is what? 2x. So after which the y dx, oh no, let's recall that u is what? X squared. Therefore, the y dx becomes 2x. We have 2x sec x squared tan x squared. And this becomes the derivative of sec square x. Okay, now we've learned a lot on differentiation, and I've been able to cover that of the chain rule, the quotient rule, the product rule, the trigonometry function. Yeah, so you try this on the trigonometry function. Try this and then drop your answer in the comment section. I've also given you one during yeah, that should be chain rule. I gave you one other assignment. So try this, drop your answer in the comment section. Also, if you have any question, on what we've done so far, maybe any difficulty when you are solving, try to let me know also in the comment section, so as for me to be able to attend to your question. Okay, see you in my next class. Remember to stay tuned. We'll be treating integration in our next class. And then don't forget to subscribe to our channel, Jeriano Tutorials, and then put it on notification, so whenever we drop a video, you can be able to see the updates. Thank you very much.